That way there will be a video. Okay, we're live. So what I'm going to do is just let me briefly tell you what our plan is for today. I will offer all of you the ability to ask questions on either P4 or maybe review the review assignment that you have, and then we will go through lesson P5, and I will give you a P5 assignment. So in order to get that thing going, I'm going to share my screen. Okay, so you should be seeing my screen now. Is that true?
Yep.
All right, good. Let's see. I got to remember how do I can't remember how to get rid of the pictures, so I'll leave them on right now. Okay, so let's open it up to questions. Questions on, let's start with P4. You may not have any, but that's okay. I know we've done this already. Any P4 questions you'd like to go through? Well, while you're thinking, I'm going to show you one came up just before we got started, and that's number 75 on P4. This problem of when you have a polynomial defector and that x squared term has something other than a 1 in it, that can be a problem. By the way, some of you are making a lot of mic noise. If you go to the top center of the screen with your mouse, you can mute your mic. The only problem is that I won't be able to hear you talk, so you may have to unmute. But some people shuffling papers, and then that gets passed on to all of us, so just keep that in mind. So if you go to the top center with your mouse, you'll see a picture of a microphone and a camera, and if you click on those, you can like get rid of your picture and get rid of your microphone. Anyway, sounds like some of you did that. It's quieter now. But before you speak, you need to go up there and put your mic back on. Okay. So anyway, as I was saying, number 75 that somebody asked about, that 6 creates a real big problem. So you can't just think x times x in the beginning. Now you got to think either 6x times 1x or 3x times 2x. And I always tell my students, try the ones that are closer together first. So you see how I tried 3x in the beginning of the first parenthesis, 2x in the beginning of the second. And then you got to play around with the 2. You can't play this riddle in your mind of what 2 numbers multiply out to 2 and add up to 1? Which 2 numbers multiply out to -2 and add up to 1? You can't do that when there's this 6 out there. What you should focus in on is the -2. What 2 numbers multiply out to 2? Good news, there's only 2, 1 and 2. So then you try the 1 and the 2, and then you check the inner product and the outer product, 3 times 1x, and you play around until you can get them to add up, positive or negative, to 1x. If you can't, you go back and swap them and try again. Maybe there'll be somebody have another question like that. So anyway, in the meantime, did anybody come up with a P4 question you wanted to ask? Okay, those of you who did not make it into the live broadcast, you can send me a text message, and I can get it that way. I'll just put my number on the screen here.
Are you still taking questions on P4?
Yeah, I'm just showing people Those of you who are not live, I said, yeah, go ahead with your P4 question.
Okay, can you do 18?
Sure. So I'm going to go to the one right before it, and I'm going to create a slide here. So this is number 8 on P4. Okay, P4 number 18. Opposed to what? Find the greatest common factor. So we have 4/5 y. Oh yeah, so we have only integers left. I'm not sure exactly what they have in mind there, but let's take a look at that. Y plus 1, 2 times y plus 1. So this is ultimately it's factoring, so we certainly could take the common y plus 1, correct? So I'm going to start by doing that. So I'm going to say, hey, there's a y plus 1 in both. I mean, there's 2 terms up here, that term. And there's a y plus 1 in both of them, so I could remove it, leaving me with what's left on the left minus what's left on the right. The only problem is they wanted only whole numbers, and we've got a fraction in there, that 4/5. So if they don't want that, how could we get rid of it? Well, let's see. I'm not sure exactly what they want us to do. We could multiply that by 5, but then we'd have to divide by 5. So I'm not sure what they want. I take it, oh, you don't have an answer in the back for this one, do you?
No.
Well, what do they do on number 17? Take a look. You know, 17 is similar. Did they have a fraction in the answer? I'm guessing not. Let's see, that's number 17. Oh yeah, they got a fraction out of there. Oh, so I see what you can do. They mean they don't want a fraction as a coefficient. Okay. Like this. And now we got to put here a number which, when multiplied by 4/5, equals 2. Well, you know, what times 4/5? Sorry, having a little trouble here with my tech. What times 4/5 equals 2? Well, wouldn't that be 2 divided by 4/5 times 5/4, which is 10/4? There we go. And of course, you could reduce that to 5/2. That's the kind of thing they wanted you to do. They didn't want a fraction as a coefficient of y. I don't know. It's not real important, to be honest with you. I'm perfectly okay with the answer up on the top, but this is, I think, what they, I mean, with this reduced to 5/2, let me reduce this. That's what, this is what they wanted you to do. Okay, but I'm like I said, I would be okay with this answer on the top also.
Okie dokie.
That's kind of an odd thing to ask you to do. Like I said, I'd perfectly be okay with the one on the top.
Okay.
Other P4 questions? Thanks for the question.
Are you recording?
I am.
Dr. Bulow?
you. Can you hear me?
Yeah.
Okay. Yeah, I'm recording, and thank you for the reminder. I do have it running, so yeah, we're in good shape.
Could we try 85 once?
85?
Yeah.
Okay. 85 coming up. Okay, so I have this one done. Let me explain what I did. So on the top is the problem the way it is in the book. The second line, I just rearranged things to put the x squared term first.
Right.
Okay.
Right.
Now, you may or may not have noticed, remember that crazy game we played with the ding, 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 ding last time?
Right.
Well, this is a ding, ding. This is a ding, ding, dinger. How do I know? Because several things. 4x squared is a perfect square.
Right.
The last term, 1, is a perfect square.
Right.
And then the third test, what the square root of the first term is 2x. The square root of the last term is 1. And what's 2x times 1? 2x. Doubled is 4x. A perfect square trinomial. Therefore, I can write the factors as a perfect square.
Right. The back of the book, because I did that too, but the back of the book had told me that the answer for 85 was 1 minus 2x squared.
Yeah, that's the same thing.
Okay.
Yeah, I can see. Yeah, and you might say, no, the sign, the negative sign, is on a different number. Well, it's only because of the squaring.
Okay.
So actually, you're right. Alternate answer here. So what they did is they left it. These are both correct.
Okay.
What they did is they left it in this order and saw that it was a perfect square trinomial. Yeah, you're right. But your answer is perfectly correct.
Okay.
Yeah, good question.
Thanks.
P4 questions? Well, let's open it up. I don't want to dominate the whole thing with questions, but ask a P review question. Some of you I know are diving in and starting to work on that because that's going to be due on Friday. Did anybody want to ask one of those? For a few seconds here, make sure I'm not getting in the way of one of you. Otherwise, what I want to do then is I want to start lesson P. I want to point out some important things from the P5 section, which is our next task. Okay, I am going to go to P5, and P5 is entitled Rational Expressions. As you can see, there are basically 6 kind of things eventually we should address. I don't know if we'll get to all of them, but there are 4 objectives. I'm probably going to skip these down here. These, I don't know. I don't know if we'll have time to talk about these 2 right here. But these are the ones we want to get going this lesson. Yeah. I mean, you'll find those in the book. They're on. They're in the section. So I'm going to dive. Let's talk about the first part. Yes. Well, I guess let's go back and I'll talk a little bit on that previous slide. So the word domain. You guys remember that from algebra class? Domain is asking what values can x take on in this algebra problem. It's actually more important to ask yourself, wait a minute, is there anything x cannot be? Okay, so I'm gonna introduce a slide. You know what? I mean, is there any kind of a problem? When can X not be a number? Well, I'm going to introduce to you the two things it can't be. Okay, actually three, but one of them is hang on. That's not what I meant. What I meant is have something like this. You can't, as you know, not in the real numbers, we can't take a square root of a negative. And then something like this, right? It's impossible to divide by 0. Please note, this is not equal to 0. This is total garbage, okay? Unless you can tell me what number multiplied by 0 equals 9. You're going to have a really rough time coming up with something. So these are, I guess I would, so what I'm saying in number 1 is we can't do this when X is a negative because we can't take square roots of negatives. This when X is 0 because we can't divide by 0. And number 3, I call practical considerations. Explain. It only happens in word problems. Let's say you're doing a word problem, and the question asks you, how many votes did the candidate A have? And what if you came up with, let's say, 3 point... Does that make any sense? Can you have 0.2 of a vote? No, not anymore in America. There was one embarrassing time in our history when you could. Black votes at one time, very early on in America, were counted as fractions. But, I mean, you either get a vote or you don't. You can't have negatives and you can't have a fraction. Or let's say you're doing a picture frame. The dimensions of the picture, that's the final question. Well, can one of the dimensions be 0? Wouldn't be much of a picture, would it, if it has no width? It's ridiculous. Neither can you have a negative. So anyway, in your mind, there are 3 issues one has to be thinking about with domain. I can never let X, I can never take a square root of a negative. So if there's a expression, that expression can't be negative. That's underneath that root. I can never have an expression where the denominator turns out to 0. So if there's some algebra expression down on the bottom, that cannot equal 0. And then number 3, if it's a word problem, just call it, you got to make common sense. You can't have negative widths, and you can't have fractional votes, and pretty obvious things like that. Keep that in mind. And now I'm going to dive into some problems. So here's one of the problems. I think somebody asked me about this today. Yeah. Somebody before class asked me about this one.
Yeah, that was me.
And the directions were find the greatest common factor. No, I'm on the wrong page now. P5. That's the bad news of questions from all over the place. Anyway, it says write the rational expression in simplest form. So how does one simplify a fraction? The only thing we really know how to do with fractions is to cancel factors. Well, if you're going to cancel factors, you have to have factors. So like in the original problem here, number 13, factor 3 times x times y, but the bottom was not. So that's why we had P4. Remind us of our factoring. So what do we do in the bottom? Take out the common factor x. Now, the bottom has the factor x, and the x's can be canceled. So that's the point of a problem like that. Let me jump ahead to number 24. So I'm going to kind of teach this lesson by doing examples. 24 says, can you simplify this thing? And the answer is not the way it is, because those are all numbers being added and subtracted. You cannot cancel. By the way, even the 7 in the top, I know the 7 is multiplied by x, but because there's addition and subtraction on the top, 7 is not a factor of the top. It would have to be a... So, but is there a way we can factor the top? Sure. Factorization. Then I do that on top and on the bottom. Can anything be canceled here?
No.
Not this time. So I would just leave it like this. Okay. Don't remultiply it out. Okay. By the way, that's a general rule of thumb. Whenever we do these fraction problems, factored form. That is because if there ever was another step, you're going to want it to be factored. Okay, so even though we factored 24, there wasn't really anything we could do to simplify that one. Let's take a look at number 28. Yeah, this is kind of an interesting one. It's up there in black on the top left. So I can factor the first part by what? Taking out a common monomial factor, y. Go further, I can also factor the y squared minus 2y plus 3. So here's the full factorization down here on the top of this fraction down here. Okay. But don't forget, you remember how I taught you how to factor the sum of two cubes? Stuck. Remember how you have a binomial and then you have a trinomial? Hopefully you remember this. Over here you put the cube root of y cubed. Here you put the cube root of 1 and copy the sign plus, and then you have a trinomial. This guy squared is y squared. This guy, this guy squared. Take the product of the two. Y times 1 is y, and then this sign is always the opposite of that one. Well, guess what? The factoring helped, because now the y plus 1s can be canceled. Again, leave your answer in factored form. So your final answer, I would really want you to leave like this. I mean, that's a good answer. Don't multiply that out on it. I mean, it's not wrong if you multiply it out. I take a chance at another mistake. That's 28. Let's jump up to 34. Here we have a graphic problem. We've got this picture, and the book says, can you find the area? Can you find the ratio of the area of the shaded portion to the total figure? So what's the area of that goldish colored thing as the in ratio to the area of the bigger rectangle? So first I got to find the areas. So my notation there is the area of the large, AL, right here. What's the area of the large? Well, length times, I'm sorry, that's little. I apologize. Area of the little. So x plus 5 over 2 times x plus 5 over 2. So on top, you literally have to handshake x plus 5 times x plus 5. That'll give you this numerator here. 2 times 2 is 4. So we've got the area of the little. Area of the big long length here, 2x plus 3. The vertical height, x plus 5. Multiply it out, and we get this guy. Well, when you simplify it, here it is. These two like terms in the middle, 10x and 3x, which of course become 13x. So now, take the ratio of the little area to the big. And now the question, so all I did was take area big and put it on the bottom, area little on the top. Although, do you notice how I joined the 4 from the denominator?
Yep.
along with. So, you know how that goes. If you multiply a fraction and then divide by something, the thing you're dividing by also goes in the denominator. And then you can simplify it. How do I know that? Well, you know that x plus, this is a perfect squared trinomial. That's how we got it. So that's x plus 5. This was a square here. I can factor this, and sure enough, the x plus 5s cancel. And there it is. There's the simplified ratio. So, I don't know. There's kind of a lot there, but it's all stuff we've done before. That's just binomial multiplication. And then our show, we had to just do a little dividing. So a simplification problem. So, sometimes you'll get a graphic problem like this one, number 34. Does anybody have a question before I move to another example? Okay, let's take a look at number 36 in the book next. And this, as you can see, is a multiplication problem. And it's all factored for us. Okay, now, this is a cool little trick have in their tool belt. You see how on top I have an x minus 3 and on the bottom I have a 3 minus x right here? Problem. Well, I sure would like to cancel the x minus 3 and the 3 minus x, but I can't. They're not identical. But a cool little trick. If you ever want to reverse a subtracted binomial, just factor out a -1 like I did right here. A -1 will take the other factor and make it. And now you can actually cancel. We can't forget about the -1. That's still there, but you are able to simplify things. And then, of course, what's left canceled with one of the x's on the bottom. So what's left? An x plus 13 and a -1 on the top. And on the bottom, we have an x squared after the cancellation and a 5. So this little trick, by the way, it only works. Well, if it's a plus, you don't need to reverse it, right? Isn't x plus 3 the same as 3 plus x? You don't need to reverse. But when you have a subtraction, these two, the way they were in this problem, were not cancelable. So if you can reverse one, you can simplify your problem, and you'll make the answer book and happy, because that's what they're looking for. Okay, let's jump ahead to 48. So, subtract fractions. Well, you have to have a common denominator, right? Yeah. And right now, do you see how in 48 we do not have a common denominator? So here we need that reversal again, don't we? So what I did, as you can tell right here, is I factored out a -1 out of second 5 minus x, and that made it an x minus 5. So, but I still don't have a common denominator. What am I going to do with that -1? Well, what's a positive divided by a negative? So it's a negative. So this whole first fraction is negative. And what happens when you subtract a negative? Is adding a positive. So now, voila. Now I have a common denominator, and even easier than that, it's an addition problem. Now, how do you add fractions? Denominator. Keep the denominator and add the numerators. Right? So like if you had 1/3 plus 4/3, keep the denominator, and you would add the numerators. So it mimics exactly what you were taught about addition of fractions way back when you were first doing fractions. How about we look at number 50 next? Keep track of the time here. We're at about noon, so we about halfway. Okay, number 50, here's the problem. This one we're going to work out together manually. I need to add these two, but I can't. They don't have a common denominator. So we got to try to figure out a way to get a common denominator. And you must begin this by first factoring the denominators that you do have. So get that first fraction. How can I factor that? Well, it's not too hard. We know it's x and x, right, to make x squared. And then I need the last term, -2. Two times 1 is 2. Will that work? So in other words, I have a product of -2. Do I really have a sum of -1 like I needed to have? Yeah, I do. Okay. Second fraction, factor. Again, easy, x and x. Well, it could be 8 and 1, 4 and 2. 4 and 2 works because 4 times 2 is 8, and when you combine, and we know it's a negative, so, I know that a negative and a positive will be like subtracting. So 4x, the inner product, and 2x, if I subtract 2x from 4x, I will get the 2x that I need. So how can I make it so it's positive in the middle? Make the bigger one positive and the smaller one negative. So now I know my two denominators. They're obviously not the same, right? Now, what do I need to get a common denominator? What do I need in the first denominator? Don't I need an x plus 4 over here that the second fraction has? And of course, if you multiply the bottom of a fraction by x plus 4, you have to do the top. What do I need in this denominator? What am I missing from the first fraction? An x plus 1, right? So top and bottom by that. Okay, now I got my common denominator. Common denominator. It's now got 3 factors, right? X plus 4, x plus 1, and x minus 2. What's this going to become over here? Well, I have to multiply, so that's 2x plus 8. What does this numerator on the right become? 10 times x plus 1 is 10x plus 10. Okay, so now let's combine like terms on the top. Wouldn't that be 12x plus 18? Denominator stays the same. Okay. Is it possible I could simplify this? I don't mean multiply out the denominator. We're going to leave that. Well, I could at least, what? Try taking, I could take, what, a 6 out of the top? Would that help? That would give me this. Would anything cancel if I did that? So even though I gave it a shot, do you see how that doesn't lead me anywhere? So, you could write it with that on the top, but you could leave it like this too. Oh, this one, same denominator. So my guess is the one on the left, these are both correct, but the one on the left is probably the one that you would find in the answer book. Does everybody recall how to do a problem like that? Addition of algebraic fractions? We probably need practice, but I'm sure you recognize the technique. Again, we're mimicking what you were taught in grade school about adding fractions. You can only add them when they have the same denominator. By the way, same is true of subtraction, right? All right, let's jump ahead to 57. I need to show you something with powers. Okay, here's number 57. Here's the problem up here on the top. I guess I should put that in a different color, but anyway, that's the problem. Say factor by removing the common factor with the smaller exponent. There's two x minus 1 factors. One of them has a power of 1/2 and the other one has a power of minus 1/2. So the book is saying take out the factor with the smaller of the two exponents. Well, negative 1/2 is the smallest exponent. So I remove that, x minus 1 to the negative 1/2 left. On the left first, well, the 2x squared hasn't changed. What do I have to take times x minus 1 to the negative 1/2 in order to get x minus 1 to the positive 1/2? What plus a negative 1/2 equals a positive 1/2? A 1, right? So I didn't write it, but in effect, on there. Hopefully all of you see that this times this would really equal that term right there. Side, it's really easy. What happens when you take out an x minus 1 to the negative 1/2? Well, just the minus 5 is left. So that's the most challenging step. Then it's just a matter of can we simplify what's in brackets? Well, there's not a whole lot. We can't really gather anything there. Could I multiply this out? Yeah, but it really doesn't do me a lot of good. Now, the book doesn't want you to leave an answer with a negative 1/2 power. So, I mean, this is correct. This is correct. This is also correct. I've removed the negative 1/2 power by, what does the negative mean? Denominator. So all I did was move the x minus 1 power to the denominator. Comments, questions? I feel like I'm doing, I don't know. I hope I'm leaving you guys a chance to speak up. Speak up if you'd like. Okay, I'm going to jump to a different kind of a problem, and that would be represented by number 61. 61. I guess some people call these compound fractions because you see how I have a fraction in the numerator, and yet, it's a fraction in a fraction. That's usually what we mean by a compound fraction. How in the world am I going to do this? Well, I made this into, I got a common denominator. I put down the parentheses here. And what I did is I took the minus 1 and I thought of it as minus 2 over 2. In other words, I just multiplied top and bottom by 2. Well, that makes it, now I have a common denominator, so the whole top now looks like this. Now I just have one fraction divided by, I guess you could think of this as a fraction, x minus 2 over 1. How do you divide fractions? Division problem. Yeah, as you well remember from grade school or high school, you rewrite the problem as a multiplication problem, the second number. So instead of x minus 2 over 1, it's 1 over x minus 2. And then a wonderful thing happens, a cancellation. So this was a pretty horrible way to say 1/2, but that's exactly what it was. So sometimes we call those compound fraction problems. You know, and the top was bad because it was kind of half fraction, half whole number. So we got a common denominator to make it, you know, we took this and we made it into we made the numerator to a regular simple fraction. And then we were able to, all right, how does one divide fractions? Oh yeah, invert and multiply. Okay. I don't know if we have time to look at it. Let's go to the next kind. Let's take a look at, yeah, 68 is a little different. Let's look at that one, okay? 68. So I have the original problem written in black. And this thing is kind of messed up because you see how it's half fraction on the top. So this is another one of those compound fractions. And then to top it off, we have some roots here. So I got to see, am I getting a text message? Oh, I do have. I see some people ask me for some review questions. Okay. Sorry, I'm slow. I'm trying to watch several devices here. So let me see what I got. So I'll try to remember this. I've got, yeah, so I've got number 40, but I don't know which section that is. And I got a question for 25, but I don't know which part. But I do have a review P80. So I'll try to save some time at the end, and I'll try to get to that one on the top. Those of you who sent me, those of you who sent me number 40 for request and 25, can you be more specific on which lesson? Okay, in the meantime, let's finish this 68 up. So just like before, I need to get this mess on the top here. I need to get this single fraction. And so you see, I stuck the second part over 1, which you can always do. And then I had to get a common denominator, the square root of t squared plus 1. So in order to do that, I had to multiply the bottom and the top by that. Well, when you do that, I don't know if you can see the detail there, but first of all, you will have this for common denominator on the bottom, so I can bring it together. And this top, you know, what happens when you multiply a root by itself? What happens when you multiply the square root of t squared plus 1 times the square root of t squared plus 1? You get that thing without the root, right? So that's this right here. And what happens when you subtract this? You sign, what's t squared minus t squared? Goodbye t squareds. And then you also have to subtract 1. See? All that's left is the subtracted 1. We got the top taken care of. And then on the bottom, you got that t squared. I stuck a 1 underneath it. And now we've got the old division of fractions problem. So rewrite it as a multiplication problem inverting right here. So anyway, that's most of it. Now, of course, what's negative? Now, how do you apply fractions? Top times top, bottom times bottom. It's right here. And then the book usually doesn't want you to leave a root in the denominator. So what you're seeing me do from here on over is just what they call rationalizing the denominator, multiplying top and bottom by the root. Two black box answers are really the same. This is the one the book wants because there's no roots left in the denominator. Let's see, did they actually put that in the directions? I gotta look. Simplify, but you're gonna see that they don't want roots on the bottom, okay, when you look in the back. So, okay, there was a lot going on there. Does anybody have a follow-up question on number 68? All right, I think we should do one like 70. 70's got all these what? Fractional exponents. Let's do that. And instead of, I think I'll do this one live. So let me get over to that one first. Then I'm going to clone it. And now I'm going to erase everything below here. Oh, no keyboard. Okay, I needed the delete key to get rid of that. So here's the problem in number 70. I believe I have it copied right. And again, we're supposed to simplify this. Okay, what in the world are we going to do here? Well, we could do some factoring on the top, couldn't we? That big top, do you see how we could, there's this term, and there's this term, right? Is there anything common to those two? Sure, the 1 minus x squared, we could take out the smaller one to the negative 1/2, okay? So I'm going to factor that top. Let's take out, I'll go to blue here. So I'm going to take out the smaller of the two, the one with the negative, and then outside that, we could also take out an x, couldn't we? Because there's an x as a factor here, and there's an x as a factor there. Leave on the top in the left term. Well, it leaves on negative x squared, right? Because negative x squared times x would be negative x cubed. And then that's it. Factored out. Okay, second term. What's left when you take out an x from a negative 2x? Well, you have a negative 2. And then, what power of x do I need here to get a positive 1/2? Again, what plus negative 1/2 equals a positive 1/2? Right? Remember the shortcut. How does one multiply exponential numbers? Keep the base and add the exponent. So when you add negative 1/2 to positive 2/2, you really do get a positive one. You really do get what you had. Okay. I'm not touching the bottom yet. Does everybody see how we got there? Big deal is, can we simplify what's in the brackets? Well, let's see what we got. I'm not touching this thing over here. Okay, what's negative? So when you distribute the negative sign, won't this be negative 2 plus 2x squared here? Because a negative 2 times a negative squared is plus 2. And then when you put that together, what do you get? You get 1x squared minus 2, don't you? Negative 1x squared plus a positive 2x squared is a positive 1x squared. All right. Now we're getting there. We're almost to the end. Let's now, here, I'm going to rewrite this way, and then I'll explain afterwards what I do. Okay, what did I do in that step? I took this thing with this thing here with a negative exponent, this thing right here, moved it to the bottom, and I put a positive exponent on it. Okay, And then the rest, I really didn't do anything else. Now, is there any cancellation we can do? Well, we have x's, right? Couldn't we cancel this with one of these? So now that'd be x cubed. Can I do anything with the x squared minus 2 and the 1 minus x squared? No, reversals or nothing or anything. It's just not going to work. So no, the best we can do is something like this. So as you can tell, things are getting a little more complex, aren't they? How are we doing here? We're on 12:20, so I should be wrapping it up pretty quickly. All right. Oh, just a comment. Take a look at number 71. Okay. In that part, you see how the directions say rationalize the numerator? So what they're saying is, do you see how there are square roots in the numerator of those fractions? They want you to get rid of them. Because that's a binomial, you got here. You got part 1, part 2. That's a binomial right here, right? What's the perfect way to get rid of that? Conjugates. So do you notice? What did I multiply top and bottom of the fraction by? The conjugate. And that makes this, look, it got rid of the roots completely on the top. What's the first thing squared? That thing without the root, x plus 2. Squared, that thing without the root, x. Yes, we passed off the root to the bottom, but that's okay. The directions were rationalize the numerator. So, all right. So let's get to the assignment. It's, by the way, it's on the website. It's the multiples of 4. It looks like this: 1, 5, 9. Every fourth one. Basically, every other odd. Do 1, don't do 3. Do 5, don't do 7, do 9, etc. Every fourth problem. Yeah, it's going to be a fair amount of work, but we've got to dig in and do it. Okay, questions? Thanks for hanging in there with me. Thanks for connecting. I hope I'll be interested in some of your reaction on how this went. When we get together in class tomorrow. So basically, anybody have any questions? So what I'm going to do then is stop the broadcast, and I thank you for attending. I will see you tomorrow.